I'll introduce myself, and then we'll go to Jessica, and then Maureen, and then Sara. So hi, everybody. I'm Kevin Sikowski. I'm a professor at the University of Toledo in the Department of Geography and Planning, and I'm part of GLOBE Mission Earth. And I'll show I'll share my screen for a second of the PowerPoint we have here. So today we're going to talk about the sky color and basically their aerosol observations. And then GLOBE Mission Earth is a partnership between University of Toledo, Wested, Tennessee State, NASA Langley Research Center in Virginia, Boston University, and UC Berkeley, and of course the GLOBE program. And these are our goals. It's funded by NASA, and trying to bring GLOBE and NASA assets to students and the public. All right, so I'll stop sharing there, and we'll start with Jessica. Jessica Taylor from NASA Langley Research Center is going to give us our science nugget, NASA nugget, I call it.
Yeah, thank you guys so much. So let me share this and see if I can make sure that it's in full screen here. Can you all hear me?
Yes, we can.
Great. Okay. So as Kevin mentioned, my name is Jessica Taylor, and I am a physical scientist at NASA Langley Research Center, and that's in Hampton, Virginia. And fun fact about me is that I was a GLOBE student, and I did atmosphere observations, including the GLOBE Aerosols protocol, every single day when I was in college. So it's really fun to now be on this side of it, and really appreciating how much the GLOBE program taught me in being a good scientist. So today Kevin and Janet asked me to talk a little bit about aerosols, and in particular sky color. And I really like this picture because it showcases an extreme example of what we would consider a really poor air quality day. And from a sky color perspective, you can't even see the sky color in that bottom picture, right? So if you were doing a GLOBE observation, you would probably even go so far as to call this an obscured sky. So an obscured sky is when more than 25% of the sky can't be seen because there's something in the way. And oftentimes it's aerosols. And in the US, the wildfires, especially the recent wildfires in the West, have caused there to be the sky completely obscured, that you can't even tell what clouds are behind there, or let alone sky color. So we're here is pretty white, gray, yuck. And so what are aerosols? Quickly, aerosols are little itty bitty particles in the sky. Sometimes they're larger particles, like ash from fire burning, but sometimes they're also really, really small particles. Those really, really small particles that are too small to be seen by your eyes are some of the most dangerous ones in terms of air quality, because you don't want those teeny tiny particles to breathe in, because your lungs don't have a real good way, or your nose is not a good means to kind of get out those little tiny air particles. So you can have natural sources. There are lots of natural sources of aerosols, like those wildfires, like volcanic eruptions. I live on the East Coast by the water, and so sea spray is actually a natural source. But there are also human caused factors of aerosols, like combustion from cars, or factories, or what we even call changes to the land. So there's both, like I said, these human-caused factors, but there are also lots of natural factors for aerosols. And this is actually a picture from the Elementary GLOBE Storybook that we'll talk about in a minute. Aerosols exist basically all around the globe, but interestingly to think about is that they don't stay in one location, right? We have air. Air is moving around us, and it's moving particles from one part of the globe to the other. So if you look in the Saharan dust area, you see that traveling across the ocean, and it lands in the Caribbean, and you can even find those little particles into Florida. And some of those particles are real important. Some of the nutrients that the Amazon rainforest gets is because of dust from Africa. But there are also, like I said, again, these dangerous sources of aerosols. And so it's important to think about this context that aerosols, these small particles, travel, and they travel around the world. Why are aerosols important to study? Well, that's because they actually are one of the many things that we are trying to better understand. So this is an active area of research, right? There are scientists at NASA Langley studying these aerosols right now and trying to figure out basically if we're having a lot more smaller aerosols, and these smaller size aerosols tend to reflect sunlight, and so they have a cooling effect on the planet, or larger aerosols like soot, they call it black carbon. Those aerosols tend to absorb sunlight, right? This is just the difference between like black and white color, which absorbs and which reflects. This is very similar to that. So you have some aerosols that warm, but you also have some aerosols that cool. So which ones are we generating more of, or which ones are the planet generating more of? The other thing is that these aerosols have an impact on cloud droplet size, and they tend to lead to smaller little droplet size, which actually reflects more sunlight. So it's a really complex situation that is happening, but we can do some interesting little observations of the sky to get an estimate of how much aerosols there are. But one of the important points I really want to make sure that I leave you with today is this idea of this is something that scientists are right now looking at. Right now we have scientists that are trying to model this. We have satellites looking down on Earth from space that are trying to count basically how many aerosols there are, because this is something we need to know. So how can you do this if you're not a satellite in space and maybe you don't have a handheld instrument to measure aerosols? Well, one of the ways we can see how aerosols impact our sky is by just looking at our sky conditions. So on the left side here, we have what the observation of sky color, which is looking at the deepest shade of blue. And I like to say this is thinking the y-axis. This is horizontally. How are aerosols distributed horizontally, vertically in the atmosphere? Whereas looking across, straight across, is your x-axis, and that's your visibility observation. How hazy is something? So when you do a sky color observation, you're going to be looking at the darkest shade of blue, the darkest shade of blue. And so typically that's going to be with your back to the sun, also because you never want to look directly at the sun. And if you were going out close to solar noon, it would be about halfway between the horizon and with the sun straight above, so that's about 45 degree angle. But you're really just looking for that deepest shade of blue, which again is often with your back to the sun. The tricky part is that you're looking for sky color, not cloud color. And so we've had some interesting days around here where you have really thin cirrus clouds that cover most of the sky. In that case, you're basically having an overcast sky of clouds that you really almost don't even see, but you couldn't tell me for sure what the sky color is because you have a really thin cloud covering it. So just something to think about. For you to really be able to give an accurate description of the sky color, you need to have a clear line of sight to the sky. And so clouds can't be completely covering the sky. Now, in a visibility observation, that's that x-axis one looking across, and you're going to look at some distant object, and over time you'll begin to kind of pick out an object and tell whether or not you think it's unusually clear, that distant object, or if it's something like extremely hazy. And the National Park Service has some really great images of this. Okay, so what's going on here? Well, a first question oftentimes asked is, why is the sky even blue? Well, when light enters our atmosphere, it interacts with a lot of different molecules, but the wavelength of light that is scattered the most is this blue light. That's more efficiently scattered by all of those little molecules. And so that's why the sky looks blue. But in the case where that sky also has a bunch of small little aerosol particles tend to reflect all wavelengths of light equally. And so they really reflect and show off white light. So the more aerosols you have in the sky, the whiter your sky will look. The less aerosols you have in the sky, the more blue it'll look, because nothing is kind of scattering all that white light. So this image I really love, again, from the Elementary GLOBE Aerosols Storybook, which are less aerosols and more aerosols, and you see those different shades of blue and what they might look like. So the Elementary GLOBE Aerosols Storybook is what's up in the atmosphere, exploring colors in the sky. And there are a number of hands-on activities, including this like cups of water with drops of milk activity to kind of get an idea for when we say these 5 different shades, categorization of shades of blue, which is a really fun one to do. I'm going to put in the chat when I stop sharing and a link to this Aerosols Phenomenon Investigation Guide that our team just developed. It's aligned to next generation science standards, but it takes you through how you might implement this in a classroom. One of the things that I like to do is start out, this is sort of the idea of starting out with like an explorer. So I like to start out with doing a sky color observation first before reading the storybook. And so there is a little web story that talks a little bit, this is called Becoming an Atmosphere Observer. There's a web story that you can access, which is how to make the measurement. But you could hop right into that data collection sheet and make a sky color observation. I like to do that first, get them engaged, and then go to the storybook. And then you can add, given time available to you in your classroom, you can add in an activity like the aerosol particle collector or like the cups of water. And then a couple other things is there are some really nice videos about aerosols or about how NASA studies Earth. And then also thinking through, okay, what is this? How does this impact me? So I'll put this link in the resources as soon as I'm done this. And last but certainly not least, I wanted to share for you from my colleague, Margaret Pippin, that she is conducting for basically the 3rd year now, I think we're going on, the U.S. Air Quality Student Research Campaign. So Margaret Pippin is a scientist also at NASA Langley, and she works with schools who are interested in studying aerosols and studying air quality in their backyard. And if you're interested in participating, we just got started because we had a little bit of issue shipping out some instruments. But instruments are available for loan to schools, aerosol instruments. If your school also wants to do this, participate by doing the sky color solely, that's okay too. So Margaret Pippin's email address is there at the bottom, m.pippin@nasa.gov. And so there will be a period of time during this research campaign where we're encouraging people to collect data, and then there will be a period of time where we're doing data analysis and having schools collaborate with one another and share some of their data. And one of the neat things about joining this campaign is Margaret is really hands-on with all of the students and teachers that participate in this. So you can basically expect to get some phone calls from her and do some email exchange with her, and she'll help you look at your data. Here's some example datas from Crestwood High School where they were comparing some of their clean sky to some of their not so clean sky. And what I'll do here also, I'm going to go ahead and stop sharing and pass it back over to you guys. But I'm also happy if you have additional questions. I'm going to type my email in the chat box here. And if you have more questions for me later on, you're always free to email me. And I can even pass along this presentation to you if you're interested.
Thanks, Jessica. All right. Well, does anybody have any quick questions? You could type them in the box, in the chat box, if you have something
Absolutely.
for Jessica. And, we'll answer those questions. But, I don't see any questions right away. Let's switch over to Maureen, and I believe it's Caleb. Is that correct?
Cale.
Cale. All right. See, I added the B, but Cale, awesome. So, Cale, it's nice to see you again.
Hi.
And I'll turn it over to you guys.
Okay. Well, we just talked about aerosols, and Cale and his partner last year, Gabe, at the GLOBE presentations, had talked about their research they had done here at school. So I'm going to let him tell you about what he did, and then I'll talk about how I use the different GLOBE protocols with the kids in the classroom. So just make sure you talk so they can hear you, my dear.
Hi, my name is Cale Jones. Up in the air and up in the air, aerosols and clouds is my project. We wanted to know if we got more aerosols at recess time or in the morning, and we figured out that we got more aerosols at recess and less aerosols in the morning, because at recess people are running all around and kicking up dirt, but in the morning people aren't really running all around and kicking up stuff. And then this is a picture of all the aerosols that we took in March. And this is a picture that we took in September of all the aerosols. And then this is a GPS that we use to locate where we are. And then we used wind speed, and then we hold it up by the string, and then it showed us how fast the wind speed is going. And then this is a soil thermometer. We stuck it in for about 10 seconds, and then we took it out and looked at it. And then it showed us how warm or cold the soil is. And then we put in the morning, we put out the pads at 11 in the morning, 11:42 in the morning till 12:27 is when we put it out at recess time. And then here's a picture that we got from the NASA satellite. And then this is our school area. And that's the day when we took pictures of our cloud covering. And we got that picture in April. And then this is the two places we put the pad out in the morning. This is where we put the pad out in the morning, and this is where we put the pad out in the afternoon. And then the reason that the sky is blue is because the blue color is the shortest wave that reflects off the aerosols. And then that's really it.
Okay. So he hasn't done this presentation since May, so I think he did a really good job remembering his project from last year. He has actually started a hydrosphere
Yes, he
project.
did. Awesome job, Cale.
He has started a hydrosphere project this year already for his project for the year. Do you want to tell him what you did real quick? Because he's been proud. He started over the summertime, so he's very excited about GLOBE.
We made
Don't tell him about your water project at home.
Okay, we made these epiphytes. Example of it. We got a pine cone, then we put water in it, then we poured grass seed, then we left it for about 5 weeks, then it grew in the grass.
He has a pond and a creek that goes through his backyard. So he's been comparing how seeds wash in and out of his watershed, and if they get onto something natural there that's not soil. So this is his version of that. He's also been testing the pond and the creek water for the year. These are basically our chia pine cones. It showed the kids that, well, he's been working on it. He showed the kids that things can grow.
Could you hold it up higher?
Oh, hold it up, sweetie. Here's his grass that grew on his pine cone. Ryegrass seeds that washed into the watershed just from his yard. So it's kind of cool to see if they could grow without actually having soil as they washed in. And let's show them. This is the other thing that we've been working on in the classroom. They're actually plastic Christmas bulbs. Put a little water in it, and I've been using the inside of a little popsicle containers with the kids, closing it. And we've hung them outside, and as we get more moisture or humidity, because we started earlier when it was warm out, it actually moves. These are our own little barometers, I guess. It gets more humid, these will stick out or come back in. So the kids have been making their own barometers in school. So they've been having fun with working on things for their own protocols. Instead of just came up with the idea one of the kids did themselves and it's worked.
Cool.
Instead of using just they know how to use all the equipment you sent. But one thing is, oh, I'm sorry.
No, awesome. I just saying awesome.
Yeah, it was a fifth grader that came up with how to build those. So they've been working on it. They're very excited. I found that
wow.
Getting them to do this, and they're finding their own hooks with stuff. I already have 7 projects that were started for GLOBE for the presentations this year, including doing things on aerosols with spraying things for natural and boughten, like weed killers. She's actually made stuff out of like seaweed and a bunch of other odd and end house stuff to see if it works better than trying to buy Roundup. That too. So kids have been working on stuff here. He was making comments that we had done some of that when Jessica was talking already for the Aerosols campaign. Kids have done the book and they've already measured stuff again outside this year. So it was his class that was on the first and second graders from last year that was on some of those posters that you guys took to the conference. So using all the protocols. So at this point, after 1 year, the kids are able to do it on their own. They don't need me out there with the equipment. So.
Oh, that's great.
That's awesome. Kayla, I love your research question, right? This idea of when do you have more aerosols? What inspired you to ask that question?
Well, it was...
Inspired means why did you want to do it?
Because I wanted to learn how aerosols started in the air.
That's great. I'm glad that you were so interested and that you were making observations, noticing kind of what was around you and being able to ask those questions. Those are exactly what a scientist does. You guys are, you and all of your classmates are being scientists right now.
Yeah. They actually started their project in September and it lasted till early April. So they did measurements once a week and he had a partner that couldn't be here tonight that did the presentation with him. So they were very dedicated, and if I forgot to be somewhere at recess out there with them, they came and found me the whole year. So they were very excited about their project. I don't know. I guess mostly for us is the kids, once I have them trained, because I have preschool through 8th grade that I teach science here, and the kids have all learned how to do all the work in their lab. I just had my preschoolers who were 3 and 4 outside doing samples in our educational garden that I have here. So they were learning how to use all the equipment and the light sensors that I have. So they were having a lot of fun with doing that and actually seeing the colors as we had. Do you have that prism in your pocket? Yeah. Okay, get it out. It's the one he had, but yeah. So our preschoolers were actually using these and talking about how we see the light in the atmosphere to go along with some of the aerosols. And we could see some of the blue reflected because we were practicing for Atmosphere Day with them too. And my second graders, that's Cale's grade, they were my helpers with the 3 and 4-year-olds. So they've learned enough to be able to help another class too. Because we have a lot of overlap with some of the classes. So we do split classes here. My homeroom is a 5th, 6th, but they do 1, 2, 3, 4, 5, 6, 7, 8 are classes. So
Great.
We want to thank them for inviting us. Let's use our manners. Thank you.
Well, thanks for calling in and filling us in on how to do this research project. It's amazing. I learned a lot, and I appreciate all you said. And boy, yeah, the aerosols are higher later in the day, so it's good to know. All right, well, let's switch over to Sara. Sara's going to talk about some of the things that Cale, oh yeah, we got clapping. Some of the things that Cale had said. He talked about his pad, the observation pad, and Sara's going to talk about how to do that.
Yeah, I want to say congratulations, Cale. That was an amazing project. I remember talking to you when you had your poster set up, and I think that you're an inspiration not just to kids but to adults as well. So keep up the good work. And just so you guys know, I actually pre-recorded this presentation, so I'm going to stop my video of my face because it may look funny when I'm not talking, but my voice actually is. So I'm going to go ahead and share my screen here. Let's see. Okay. Gotta hide that. Okay, can everybody see that?
We're good.
Okay, all right, I'll go ahead and hit play. Hi everyone, this is a mini tutorial that I put together to tell you a little bit about elementary globe, specifically the What's Up in the Atmosphere storybook and the activity called Up in the Air. So to find all things pertaining to elementary globe, you go to the GLOBE homepage, which just recently got an upgrade. And under Do Globe, you'll see the listing there, and there's elementary globe. Click there. On this page, you'll find all sorts of things for K through 5 globe activities. And if you look on the left-hand part there, you'll see climate, earth systems, clouds, etc. All the way down at the bottom, you also see discussions and group documents for conversations. And if you scroll down on that same page, you'll see the icons for all the different storybooks for elementary globe. The one on the bottom right is the What's Up in the Atmosphere storybook. And after you click on that, you can download it for printing. You could also download the ebook. And there's instructions there as well for the ebook. On the left hand, you'll see there's a learning activities link, and that's where we'll go next. After you click on that learning activities link, you'll see the different ones available for aerosols, including sky observers, why not so blue, see the light, and then the last one is up in the air. So the up in the air activity we also call the sticky grid activity. And that's for students work in groups to make an aerosol sampler, which is a simple adhesive tool that allows them to collect data and estimate the extent of aerosols present at their school. And the purpose of this is to introduce the students to aerosols and help them understand that there are small particulates in the atmosphere, and engage the students in collecting, analyzing, interpreting data, and making predictions. And also to tell them about the concept of random sampling. So after you click on that link to download the activity, this is what you'll see, the full activity sheet, which includes instructions, materials, the time required for the activity, as well as a bunch of teacher notes and suggestions for further follow-up. So in these next few slides, I'm going to show you just a quick version of this activity and with some pictures thrown in directly from the What's Up in the Atmosphere storybook. So the first thing you want to do is introduce the activity to the class, divide the class into multiple research groups, and ask them to describe what they see in the sky. Ask them if they've ever noticed small particles in the sky, and say that some aerosols are too small for our eyes to see, but other aerosols are larger, such as dust or ash. And explain to them that today they can go outside to collect data about aerosols around their school. The students will probably have lots of questions about what aerosols are, and the book gives you this image and some information on the different types of aerosols and where they come from, which can include natural sources such as volcanoes and fires, and human sources such as factories and cars. So within the activity sheet, you'll see this aerosol sampler grid along with some instructions on how to make the sticky grid. Basically, you cut this out and you adhere it to a square piece of cardboard and cover it with sticky paper. So once your student groups have created their sticky grids, you can take them outside and have them place them in various locations around the school grounds. So the students will leave the sampling grids outside for at least 2 hours and then go back and then collect them and bring them to the classroom for analysis. And I won't read through all of these instructions here, but the idea is that you'll roll some dice, and then with those dice you can determine randomly from which grid location you will add up the number and count the number of aerosols that you see. So you do this 10 times, so you'll get 10 random grid squares, and then you add that for a total, and then divide by 10 to get the average number of aerosols for that location. And then you can use those results and compare them between student groups. And students can record their data on the Up in the Air student activity sheet. And this can include weather information, such as were there clouds, was there precipitation, was there wind, what was the visibility, the temperature, etc. After the students have recorded all of their data, then you can have them share out their results. They can discuss, for example, which locations had the highest number of aerosols and why do they think that was the case. And then which locations had the lowest numbers of aerosols and why. And also you can ask them, do they think that weather played a role in their results? So after the student groups have shared out their results, you can then tie this into a discussion about aerosols and air quality. And you can use this image that was taken from the What's Up in the Atmosphere Storybook and talk about how perhaps when there are higher levels of aerosols in the air, that may be unhealthy for sensitive groups, such as those with asthma. And then how when there are lower levels of aerosols in the air, that can be better for people. Thank you for listening to this mini tutorial. My name is Sara Mierzwiak. I'm a research assistant with Globe Mission Earth. And the What's Up in the Atmosphere Storybook, as well as the Up in the Air activity, were created by all these wonderful Globe people shown on the right. Thank you.
Yeah, I notice Jessica's name's there. Good job, Jessica.
It was a labor of love.
There you go. So thanks, Sara, for sharing that. That was a nice video, and some people asked if you could share that, put it on our YouTube page. I think would be a good way to do it.
Yeah, absolutely. And if you guys have any requests for future mini tutorials, let me know.
And I think you'll start to become like, I forgot the guy's name at Globe Implementation Office that does this, makes videos.
It's actually kind of fun to do.
Yeah. Oh, no, all right, nobody's, no, not Travis. Roller, there you go.
Roller.
Yeah. Yeah, Roller makes videos. All right. Well, thank you. And yeah, if anybody has questions, post them in the box, or you can unmute yourself and ask those questions. All right, I'm going to share my screen and we'll do some follow-up here. Let's see. Okay, so one of the things we want our kids to do are do projects. So just to give you an update, International Virtual Science Symposium projects are due March 1st. And this is a great opportunity for your kids to share their research with the world. You know, basically make a video, or you can videotape the kids in front of a poster. You could also do a narrated PowerPoint, that type of thing. And you upload that, and then scientists from around the world actually review the projects, and then they assign stars for how, or badges they call it, sometimes badges, how well they do in different categories, and the rubric is here listed. Now, I'll get to that. Oh, I'm thinking something else here. But then I wanted to mention the U.S. Regional Globe Science Symposium, another place where students can present. And so our Midwest one is going to be May 18th and 19th at Wayne State. And then we have the East Coast will be in Fredonia. And then the Southeast and North Carolina, April 19th and 21st. Lastly, the annual meeting for GLOBE is going to be in Ireland this year. Cool. This is a great opportunity for kids to meet other students from around the world and scientists from around the world. And now from the virtual science fair, 2 U.S. teams will be chosen, teams that get all 4 stars for achieving all the goals. Will be put in a random drawing, and 2 teams will receive $2,000 towards a trip to Ireland to present at the annual meeting. Okay, so we're going to have a follow-up with students on probably Friday. So I wanted to take a poll here. And who can do this on Friday at 1 o'clock Eastern time? Look at the chat to see what's going on in the chat. Okay, so I don't think, so if you could post in the chat if you plan to be on, if Friday at 1 o'clock is okay, Eastern time, for the student webinar. Okay. Okay. Yeah, the site is working as far as I know. So I put the link here. I think some of you got this link, or you should have gotten it. And the idea is, before we do the student webinar, we want the students to take the sky color observations on Wednesday, Thursday, and Friday. And so then we can look at that data. Okay, so Deb won't be able to do 1. Okay, you might have observations. Kara Del Sol. Don't know if I know you. Oh, okay, so yeah, the GLOBE website's actually back up. All right, so I'll stop sharing.
Ah, there we go. That works.
All right, so from what I see, it looks like most everybody is going to be in school on Friday, and that people are going to try to come on. So I'm thinking we should stick with Friday at 1, and hopefully we'll get some people.
Hi, Mikkel. Nice.
Oh, hi, Rebecca. Good to meet you, and I'm guessing you're in Tennessee.
Yes.
Cool. All right, so yeah, let's stick for 1 o'clock Friday. Now, this is Eastern time, so of course Central will be noon, if anybody's Central time. I don't know how Tennessee works with time zones. Are you guys in Eastern? Okay. Oh, how long will the thing on Friday last? It usually didn't last too long. We did about half an hour a couple months ago with the solar eclipse, and so it wasn't too long. And wanted to basically have the kids come in and out. We learned a few things. We won't ask the students to say anything. Basically, if students have questions, they can type them into the chat box, And actually, it's great if the students can prepare questions ahead of time, and that way, you know, we can you know, have those questions for people to answer. Okay.
So Kevin, if you ask them to put their email in the chat box, and then I will send the link to them so they don't have to copy down the long address.
That's a great idea. So yeah, if anybody who plans to be on Friday, or even if maybe you're not sure, please put your email address in the chat box, and that way we'll get information to you. And there's the link. Jessica posted it. I think that's it.
Oh, no, that's the for the elementary globe stuff. But actually, Janet, could you post the Google link?
It'd be easier for Kevin because I'm recording.
Okay, let me see if I can do that. Now this is the link. Yeah, this is the Google link. Sorry for my clumsiness. See if this worked. Hey, look at that. Sent to everybody. Okay. Cool. You know, I really appreciate everybody coming on tonight. We had a good audience, and you know, I wanted to thank all the speakers. So Jessica, awesome job. Thank you, and learned a lot about the aerosols. Maureen and Cale, great job with that too. And then Sara with your tutorial. I think it worked out really well. And there's going to be the next, Janet, can you remind me, what's the next webinar going to be?
December 7th, I think it is.
Okay. And is that the one David Padgett from Tennessee State is going to lead?
Yes.
Okay, so that's the plan. David Padgett from Tennessee State will lead the next webinar December 7th. All right, cool. All right, everyone, thank you for coming on, and we'll keep collecting these emails as you post them. And I wanted to, well, and we're right on time. Awesome.
Well, there must be a correction because the 7th is a Thursday, so it's got to be December 5th.
Okay, December 5th.
That's what I wondered.
Today's the 7th, isn't it? There you go.
Yes, but I thought it when we did the notes, but it's December 5th because that's a Tuesday night.
Yeah. All right, well, thanks. Thanks,
Thank you,
everyone,
Cale.
for calling in.
Yeah.